Thank you for joining us. The global economy has been plagued by supply chain constraints in recent years, and high-growth transition industries such as renewables have been challenged to get the right things in the right place at the right time. And innovation has to be in the center of the solution to this. It cannot just be about mining more metal, making more stuff to solve supply chain constraints. My name is Sam Wilkinson. I'm a director in the Clean Energy Technology team at S&P Global, and I'm joined by a great panel in this sector. We've got Mark Lundstrom, CEO of Radia. We've got Yi Choi, who is a professor at Stanford University. And we've got Justin Britt from Bechtel. Now, Yi, you've founded 6 companies, you told me, which is makes you an expert in innovation, I would say. So when I say innovation and supply chain, what's the first thing that you think of?
Innovation and supply chain are certainly very closely linked. When you invented a new technologies, the basic element going into that technology could change. And for example, if we work on lithium-ion batteries, where you rely on lithium, cobalt, manganese, and you have copper, foil, and so on. But once you change to sodium, things start to look different. So first, you remove lithium, and your cathode material, your anode material could be different. And when you move to solid-state batteries, this create a huge difference also. Once you move on to aqueous electrolyte batteries, now it suddenly open up completely different supply chain. Your electrolyte is different, your solvent is different, your cathode anode will be different. So innovation is super, super important to really determine how your supply chain should look like. Given the energy transition, the scale of the problem we need to get into is so big. It's really worth to think about scale right at the beginning for innovation that coupled with the supply chain. At Stanford University, indeed, I'm leading our Sustainability Accelerator. It's a new unit at Stanford right there. We have been talking about in the past roughly a year and a half, how do we do innovation? Put a scale right at the beginning, whether it's energy technology or it's water, it's a sustainable food, it's other topical areas. Based on that, and then you look into supply chain issue and see whether it's possible to really establish a supply chain that get you to gigaton level of materials, that get you to terawatt hour type of unit. Well, I'll pause right here for now. We can go deeper just in a little bit, yeah.
But I'm hearing about technology advances and material substitutions, changing supply chains, reducing the amount of material that we need. Justin, what does Bechtel do that's innovative to help with supply chains?
Well, as a builder of new plants and new capacity, and as well as recycling, we're always looking to figure out, is a constraint in the supply chain a permanent one or a temporary one, and therefore requires a different solution. We've invested hundreds of millions of dollars in the last few years on digitizing our supply chain, and trying to get systems that didn't talk to each other before to talk to each other now. And that enables, for us as an engineering, procurement, and construction team, those groups to now talk to each other and get down to an individual module level, and be able to see that if a component is maybe going to be late to a site to enable a new plant to be built, for example, one of these startup companies, then the construction crew that was going to go work with that component on the day can now move to another area. It keeps everyone productive. It helps the schedule. It helps reduce waste. It helps reduce cost. Also, you also see now, for example, we just had an issue on the Strait of Hormuz where we had difficulty getting materials, and we can, with good data now reroute different shipments to different sites. And being a global company, we're buying stuff all over the world. We've got projects all over the world. We can do this on-the-fly adjustments to our shipping and keep things flowing. So,
and Mark, people talk about elephant in the room, but today we've got an aeroplane in the sky. I've got to ask you, how does an aeroplane solve supply chain constraints?
Sure. There's so many different important aspects of supply chain to get right for the energy transition. There's materials and mining, digitization. We look at opportunities in transportation and transmission ultimately. And so there's this opportunity, we believe, in the world to make onshore-sized turbines the same size as offshore. And so the industry knows how to make offshore-sized turbines that are nearly the size of the Eiffel Tower. And so one would ask, why are we not distributing those turbines to onshore locations where the market is perhaps 10 times bigger? And it's not a technology issue, it's a transportation issue. And so you're right, we've designed and are in the process of getting built what will be the world's largest aircraft, the Windrunner, conveniently modeled stage right. And so this vehicle will allow us to move up to a 105-meter long blade and be able to land these blades in the middle of a dirt wind farm. And so this will unlock hopefully trillions of dollars of new capex in the world of onshore wind and be able to make a significant reduction in the cost of wind energy, a significant increase in the capacity factor, and the hope is to be able to triple the acreage in the world where wind is economically viable. And then of course, by doing all this, you can end up doubling the profitability of wind energy projects.
Okay, that's super interesting. We've talked a lot about materials and production here, but one of the constant things that comes up in supply chain conversations for me is labor, shortage of labor. So Justin, maybe you can just tell us a little bit about how you're addressing labor shortages with innovation.
Yeah, so it's an interesting time, right? We're in the busiest construction wave probably in the history of the country. Probably going to hit about $200 billion a year in the U.S. with everything going on. And so there's huge demand for labor, and at the same time, the labor workforce on the construction side is retiring faster than we are filling it up. And so that gap will continue to grow. So how do you address a gap? You increase supply, you decrease demand, or you make the existing workforce more efficient. Increasing supply. So one of the best ways you can do that is by attracting more women into the workforce. About 47% of the overall workforce is is female. Actually, in construction, it's 4%, which is kind of embarrassing to even say. At Bechtel, we're about 8%, but still a long way to go. And so even if you took that 4% to 4.5%, you're going to add tens of thousands of new craft professionals to the workforce. And we know the administration is pushing for this. There were some ties as part of the CHIPS Act funding for this, worthy initiative. Veterans, you can, helmets to hard hats, people coming back and looking for that second career after serving their country. And then thirdly, you can import labor. It's challenging. It's a complex visa process, but you can get it done if you have the right partner. Decreasing demand. That's usually shaving the peak off the labor curve on a project. And that's about largely modularization, getting some of the work off the site. So modularization is about taking a project and kind of Legoitizing it a bit, and then building the Legos somewhere else and bringing them to the project site for final assembly. Lots of good strategies you can apply there. It is complicated. You need to think about it from the beginning of the project. And then thirdly, making it the labor more efficient. So that's about getting the right information to the right people at the right time to make the critical decisions and giving them the proper training. So working with local trade schools, working with the local unions if it's a union job, giving them sometimes some of these new, especially in the manufacturing space, will have special skills required like orbital welding or plastic pipe. And so getting people the right skills to progress that.
Mark, how does your product, how does that help with labor shortages?
Yeah, I guess it's not intuitive when you think about why we started the company and why we are building the Windrunner. It wasn't the principal purpose of the project, of course, labor savings, but when you actually then start to talk to the EPCs and the turbine manufacturers, there's an incredible amount of labor, of course, that's involved in transporting a turbine blade for 1,000 kilometers. Typical turbine is transported 1,000 kilometers between factory and wind farm. You can imagine every county line you go across, you change the precedent vehicle and the chase vehicle. And then also the big shortage in the world of wind energy, of course, on the labor side, are the number of skilled technicians that can actually install large turbines. And so the beautiful thing about the bigger turbines that the Windrunner enables is that you need half as many of them per gigawatt that you install. And so with half as many turbines, much less labor that you need to do the installation of a wind farm.
Okay, Yi, I'm going to come to you. You've got 6 startup companies, you said to me, presumably each one of them trying to scale up. Each one of them must be facing supply chain challenges. What for you is the biggest supply chain challenge in getting a company from the lab to the factory?
So the 6 company, maybe let me pick a couple company more on the battery space. My first startup company, Amprius, is working on silicon anode, which can store 10 times lithium compared to graphite. So this allows you to about nearly doubling the energy density of the lithium-ion batteries for electrical transportation, for aviation. So using silicon replace graphite, first of all, this innovation changed the whole supply chain. Right? Graphite is made by this high temperature using this organic precursor to generate graphite crystal. Now silicon is based on silane process. It's silicon H4 molecules, gas decomposition. Your processing is completely different. First of all, you need to have processing innovation. And then when you do the scale-up production, you're going to find out, hey, nobody ever produced such a high surface area to throughput before. It's a huge challenge right there. Even though Amprius already IPO about a year and a half ago, 2022, but building up the whole factory right now, for the first time, use this type of process for batteries is new. So once you have a new process, just imagine the degree of challenges you are facing, all the equipment suppliers, right, all these material suppliers need to go through the environmental assessment, and everything is new. I mean, this is the challenge you are facing. But once this is done, right, you say, well, I copy the second line, this is going to get faster and faster. And another company on grid-scale energy storage is Inovanio. This is a company using nickel hydrogen gas batteries. It's an aqueous solution space using nickel as the cathode, nickel hydroxide. Anode is a catalyst. And it's really a gas cylinder right there. It's also completely new type of battery manufacturing, different from lithium ion. So it's innovation in the technology and also innovation in the manufacturing line as well. Then you say, hey, where do I look for all this equipment? I need to look at global sourcing. It's not trivial to put something together like this for the first time. I would say this is challenging we are facing. If you ask me 3 years from now, and the degree of challenge might evolve from gigawatt hour scale to talking about 100 gigawatt hour scale of production. Then your whole supply chain, the scale of the problem change. Then we are going to face different type of challenge. I'll pause right here.
Justin, you told me when we spoke earlier that Bechtel helps small companies, startups to go from the lab to the factory. How are you helping companies like Yi?
Well, it certainly varies by company because some companies have great primary process engineering capabilities and know exactly what they want and just want someone to help put it all together. And some companies want a partner to do the primary process engineering with them, especially on the materials side. And so what's interesting is doing a very large scale project, in a traditional way is a relatively rigid process. Folks want to know the end, and they want to work there, and engineers love a good process, right? And working with a startup it's different every day. It changes, the needs change, and so both parties have to kind of adapt to each other a little bit to make it work. And one of the advices I give is usually know what you're solving for. You can't know everything in the end, but at least know if you're trying to solve for the lowest unit economics, the minimum viable product, the first product out the door, the final schedule on the last product, and that will help you make decisions along the way.
And Mark, what bottlenecks is the Windrunner facing right now?
So when you're designing what will be the world's largest aircraft, you can imagine there's a lot of supply chain issues you have to keep in mind. But the best way to mitigate that risk is actually to design the aircraft around the components that are already in mass production and already certified. And so the team has spent years working on a design that does just that so that we can rely on the main components that are already in mass production. The other thing to point out in terms of supply chain, with the bigger turbines that the Windrunner enables, one of the biggest constraints in the energy transition is the amount of transmission cables that can be deployed. Transmission lines are scarce, they're hard to permit, and the transformers are also a big scarcity. And one of the beautiful things about the bigger turbines is they operate in much, much lower wind speed. And as a result of operating at lower wind speed, you can get your generating capacity much closer to your demand center and reduce the amount of transmission lines, transmission permitting, transformers, and that should be a great accelerant to getting a larger amount of wind deployed in the world.
Okay. In a moment, I'm going to ask if any of you have got questions for the panelists here, so get ready. And hope that you've got some good questions. But I want to talk about localization, because you can't talk about supply chains without talking about localization. And I'm going to ask each of you this question. How has localization changed the way that you're innovating and designing products?
So for us, we do view our supply chain as a very global supply chain, and it's very important, I think, to engage different parts of the world in the supply chain, because the manufacturers, the top manufacturers, are indeed globally located. So we haven't, on the aircraft side, we haven't looked so much in terms of localizing the components, but we've definitely thought about where to manufacture the aircraft that's going to be manufactured in the United States with a global supply chain has been our strategy.
Yi, does localization change anything for you?
My first reaction is just so unfortunate the geopolitical reasons made the supply chain localized. It's not an efficient use of global resources, but looks like this is an unavoidable trend. So how do we do that? I mean, in the battery space, for example, again, if you look at the supply chain, it's not here. It's very, very challenging to build this supply chain. Then how are we going to go about doing this? I would say there got to be a transition moment right here. It will take multi-years. If we are smart about how to build supply chain here domestically, we got to engage international partners to set up the operation right here, train our workforce, teach us every step of how do you make copper foil, how do you make graphite, how do you make lithium cobalt oxide, lithium iron phosphate, how do you make solvent, how do you make battery separator, how do you make the tiny can. It's just every single component needs to be reinvented right here in terms of manufacturing. It's very, very challenging. I hate to see this, its localization is really slow down our speed of clean energy transition. But is there a middle ground of transition solution we should pay attention to? I believe we should explore that and create a win-win situation. Instead of having just a clean cut, I mean, just that will be become a nightmare for us to handle right here.
Justin, is it critical or inefficient?
It depends. But I would say that globalization is a huge part of our business, both in helping customers go global as well as come to domestic markets. And we execute our projects globally. We have several thousand engineers in India and other locations. We've seen a real change, I would say. If you rolled back 30 years ago, our manufacturing business was largely about helping Western companies go to places like China. And now it's largely about helping companies from Asia come to the US with the skills that we were just talking about. And global sourcing, we talked about that a little early, it can really be a trade-off. It is often a very good strategy if you have enough time, because you can generally save money, but it takes a little time to get the materials to the US. However, it can also go the other way. If the US is a constrained market, has a supply constraint, for example, on transformers right now, you can get them overseas faster, but you actually might pay a premium. So it's a trade-off that you need to decide for each project.
Okay, now's a good time to see if any of the audience feel like they've got a question they'd like to ask. Okay, we've got a question over here.
I have a question, also related to the localization you mentioned just now. I think the best word to describe the supply chain, the resilience, is actually global. It's global plus local, so localization. So my question is that during the process of scaling up the technology, for example, change the order of magnitude, how does that impact the localization, or the other word is the resilience of the supply chain? Thanks.
Okay, so as we go from a small startup to a global manufacturer, how does that change the resilience of the supply chain? Yeah? I guess, Justin, is that something you'd like to talk about?
Well, certainly, even at the startup levels, what we're seeing is collaborations between, for example, U.S.-based companies and partners in Korea and China on the battery supply chain, because that's where a lot of the key knowledge, lives right now. And so I think it will continue to be partnerships. I don't think we're going to live in a world where everything is isolated to, one country or one location. It's going to continue in that way, and I think that will result in a better outcome for everyone.
So this is a great question. Once you go to global scale, this put a lot of stress on supply chain again, whether it's localization or globalization supply chain. I want to bring in another thought into the discussion we have not touched upon. And the circular economy needs to come into play to help reducing the strain, the stress on the supply chain. You have this battery technology, you have other technology. You cannot say, I throw this into the trash. You need to establish very effective environmental footprint, very little environmental footprint for the whole circular material to flow. You don't want to waste lithium, cobalt, you don't want to waste manganese, nickel. This got to go into a flow. Eventually, these are self-sustained and certain level. I hope in 15 years, 20 years, we already established electrical vehicle to this scale that the retired electrical vehicle coming back allow us to produce more materials for electrical vehicles. Everything needs to think about circularity.
Mark, what's the Windrunner doing to promote circular economy?
Yeah. So one of the biggest challenges in the wind farm business is what to do with the turbines and the towers when the farm is being decommissioned, right? So eventually, farms are decommissioned, it's repowered, and you put in the new kit, but then do you take out the old, right? Because it takes 18 months typically to plan the movement of a big turbine blade from factory to wind farm. So you make that investment when you're installing your wind farm. Are you going to make that investment when you're throwing away the turbines to get ready for the next? And so one of the things that we've been working on as well is being able to bring out the old when we bring in the new. And as recycling starts for blades, it'll make sense that these are not done in a localized recycling center, but instead a centralized recycling center that will probably be next to a factory where the turbine blades are being produced in the first place.
Any other questions from our audience? Over here.
This is for Mark. That is an impressive piece of kit to fly cargo, but can you talk about landing it? What would you have to do for permitting? What do you need in terms of how much, land to land it?
Yep. So even though it's a gigantic aircraft, 12 times the volume of a 747, 9 times the volume of an Antonov, it unusually can land on dirt, and that dirt strip can be about 2/3 of the distance of a 747's requirements, for example. And so it's designed to be a relatively short takeoff and landing aircraft, has a very big wing, and that allows us to land closer at the speed of a Cessna than at a 747. And so it comes in slow, allows us to land fairly short, and then for taking off, it has it's just overpowered with thrust. And so we're able to, we have 4 engines instead of the same engines that would be on a commercial airliner where they'd have 2, we have 4. And so it has a thrust to weight ratio that's comparable to a fighter jet when it's empty. And so that's one of the special things about the vehicle, and it's the first time I think that a vehicle has been designed to optimize around volume instead of mass. And so it has some, and that helps with the uniqueness of the short takeoff and landing capabilities.
Are you going to take the first ride on it?
I hope so, yes. I'm planning on it. I guess that's my decision, isn't it?
Any other questions?
Hi. The topic has come up a few times about permitting. And so I'm just curious if any of you have other experiences with, as we look to implement cutting edge technology, if you believe that permitting processes are and the regulations around that are consistent with supporting this, or if you have any experiences that you'd like to share with us on how we can do better in that area.
So we got to nearly 4 minutes to go without mentioning permitting, but we're going to have to tackle it, guys. So, permitting has to surely affect everything that you do, but just in permitting for factories.
Yeah. Obviously, if it's an established process, an established area that's pre-permitted, great. but it often is. And in fact, in the U.S., we're running out of kind of pre-permitted sites that have good power, right? And right now, frankly, power is probably the biggest constraint for building out new plants. But especially if there's a new technology, and sometimes that new technology it doesn't even sound that new, but it's new to the local person because we have this multi-tiered regulatory system in this country, which is very different from some other places. And sometimes it's you have to get the local fire marshal to understand your chemistry, and that's your bottleneck. Not you need something at the federal or state level. And so it is definitely a constraint. But I think with proper early engagement, collaboration, you can get there.
Let me add a little bit. This is what I heard from my CEO, for one of the companies. I said, how come our factory has not come up and running yet? Then he was telling me, he said, hey, by the way, to get the the residents to sign up, allow you to build a factory, just collect that signature can take a year. I say, that's one type of permitting. Giving you one example. I was trying to dream about how Elon Musk built a Shanghai factory within 9 months. Like, can we do something like that within a year instead of spending 3 years to 4 years to build a battery plant? Other plant, I don't know yet. I'm just thinking about this. Maybe I'm only telling you the problem. One problem, I said, wow, I didn't know about this. To build a factory, you need the local residents around neighborhood all sign. Otherwise, you cannot build it. I say, that takes some effort right there.
Just to clarify, what you're saying is that in the US, you're trying to build a factory, because you mentioned to me earlier, you're building 2 factories right now, or trying to build 2 factories right now, one in China, one in the US. And you're saying 3 years of permitting process in the US, but Elon Musk can build a battery factory in Shanghai in 9 months.
There's a huge difference right there, yeah. And I don't know all the details where the permitting is the slowest way, but I'm learning it. So I think that's why you should ask great question. The permitting is amazing. This can be a roadblock to build manufacturing, to build up your supply chain.
Well, we don't have Elon Musk here to ask, but we do have Mark. So Mark, what about permitting for your manufacturing?
Yeah. Well, first I realized I dodged Mike's question on permitting of a landing strip, and that's surprisingly easy to do. If you're trying to make a new airport, very hard. If you're putting a landing strip in a wind farm, relatively easy. Certainly easier than the cumulative permits that are required for transporting a blade 1,000 kilometers on the road. And then with regard to permitting the larger turbines themselves, it opens. First of all, you have to permit half as many per gigawatt. And so that's a huge advantage. And then also you're able to move some of these wind farms into areas that have not been previously viable for wind energy. And so there's huge opportunities in being able to go into the parts of the world that do not yet have wind farms and be able to have easier times of permitting, easier times of getting interconnects, easier times of transmission lines. So on balance, even though they're very tall, we think that the permitting challenge is ultimately easier.
Okay. At this point, we're going to have to wrap up. We could happily carry on talking all day. I think that the one thing that I was not expecting to hear about today is actually how localization is having a negative impact on innovation, and how we need to improve our globalization and we need to improve our permitting processes to really allow this innovation to solve supply chain challenges. And I think that's super interesting and something that I'm going to take away from this today. So I'd just like to thank my panelists. I'd like to thank all of you for coming along and listening and for the great questions. And please enjoy the rest of your day.